Let's dive into NOCUST security. So what happens if a NOCUST operator disappears just after a checkpoint? So let's recapitulate. So we have here an operator. The operator has a set of users, and at some point in time the operator becomes malicious. Let's assume that's not right at the beginning, right? So at the beginning the operator starts by submitting a Genesis checkpoint, though the off-chain hub starts to function. So now after 100 transactions, right, you can see here, after let's say 36 hours, there's a first initial checkpoint submitted on-chain. After another 36 hours, there's another checkpoint submitted on-chain, and this other checkpoint here accounts for another 100 transactions that are being performed off-chain. Now, the transactions 100, so 1 to 100 are committed on-chain, and let's say they're safe because they were committed on-chain. For simplicity here, we ignore like additional delays or so. So they can be withdrawn anytime, right? So this means here we assume that once it's committed, it's final. Now, what happens if the NOCUST server disappears after a few transactions were performed past a checkpoint? So again, we assume here the NOCUST operator, he submits a Genesis checkpoint, then there are 100 transactions that are being performed, they are submitted in a checkpoint, another 100 transactions that are performed, and then let's assume there are like 30 transactions, additional transactions that are performed, and then the operator disappears. So the transactions 1 to 200 are safe, right? So these few transactions here are good. There's nothing that can happen to them. And the transactions 200 to 230 are not committed on chain, right? So these ones here, they're actually lost, right? Unless there's an insurance pool that recovers the transactions. But this requires the adversary here to add an insurance pool for these particular transactions, for transactions in general, like for each user. He needs to allocate for each user how much money they can receive in a round. Yeah. So this is what is the difference between instant finality, which happens if we have an insurance pool, or delayed finality. In delayed finality, it can happen that your transaction is not being confirmed, and you should wait until it's confirmed before you accept the payment. So now let's discuss double spending on NOCUST. So how can users perform double spending? So let's assume we have Bob here. He wants to perform a payment to Alice, and that's a 50 Ether payment. And let's assume he also wants to perform a 50 Ether payment to Bob. Well, the second payment to Bob will not go through because we have the central operator, and we assume for the time being that this central operator is benign, and he will hence not forward this particular payment. Now, what however happens if the NOCUST server colludes with the client to attempt double spending? So in that case, actually double spending succeeds, right? So Alice will receive her 50 Ether, and Bob will receive back his 50 Ether somehow. However, this means that the adversary Bob here kind of tries to create coins, right? And if the operator tries to create coins, then the smart contract will say, well, I don't have 100 Ether in the contract, I only have 50 Ether in the contract. So this means the operator is challenged on the smart contract, right, and will be shut down. The other way that this could work is if Bob and the operator, they try to steal the 50 Ether from Alice, right? And then Alice would basically go on chain, check the checkpoint, verify the checkpoint whether it's actually properly representing its balance. And if that's not the case, well, then the operator gets challenged.